Next question number 7. If y equals to 6x to the power 5 minus 4x to the power 4 minus 2x square plus 5x minus 9, find dy over dx at x equals to minus 1. So first we will find the value of dy over dx. For that we need to differentiate the given function. So here y equals to 6x to the power 5 minus 4x to the power 4 minus 2x square plus 5x minus 9. So let us differentiate both sides with respect to x. Then we will have ddx of y equals to ddx of 6x to the power 5 minus 4x to the power 4 minus 2x square plus 5x minus 9. So this implies dy over dx equals to, let us distribute this differentiation to individual terms, minus ddx of 4x to the power 4 minus ddx of 2x square plus ddx of 5x minus ddx of 9. So this will be equal to, now since 6 is constant, so 6 ddx of x to the power 5 minus 4 ddx of x to the power 4 minus 2 ddx of x square plus 5 ddx of x minus 0, since 9 is a constant. Now this equals to 6 into ddx of x to the power 5 is 5x to the power 5 minus 1. Now 5 minus 1 is 4 minus 4 into 4 x to the power 4 minus 1, and 4 minus 1 is 3. Okay, minus 2 into ddx of x square is 2x to the power 2 minus 1, and that is 1, plus 5 into ddx of x is simply 1. So this will be equals to 6 times 5 is 30, x to the power 4 minus 4 times 4 is 16, x cube minus 2 times 2 is 4x plus 5. So this is the value of dy over dx. Now we have to find dy over dx at x equals to minus 1. So for that we need to put the value of x equals to minus 1 in the value of dy over dx. Therefore dy over dx when x equals to minus 1 equals to 30 into x, in place of x I have to write minus 1 to the power 4 minus 16 into minus 1 cube minus 4 times minus 1 plus 5. So if I simplify this, it will be 30 into minus 1 to the power 4 is 1 minus 16 minus 1 cube is minus 1. Minus 4 times minus 1 is positive 4 plus 5. So this will be equals to 30 minus 16 times minus 1 is plus 16 plus 4 plus 5 is 9. So if I add, I will get, the answer will be 55. Next we have, if y equals to 2 minus 3 cos x over sin x, then find dy over dx at x equals to pi by 4. So here y equals to 2 over sin x minus 3 cos x over sin x. So this implies y equals to 2, 1 over sin x is cosec x minus 3 times cos x over sin x can be written as cot x. So now let me differentiate both sides with respect to x. Then it will be d dx of y equals to d dx of 2 cosec x minus d dx of 3 cot x. And this implies dy over dx equals to, since 2 is constant, so let me write in front, d dx of cosec x minus 3 times d dx of cot x. So this implies dy over dx equals to 2 times d dx of cosec x. As you can see the formula here, d dx of cosec x can be written as minus cosec x into cot x. So it will be minus cosec x into cot x minus 3 into, now d dx of cot x is minus cosec square x. So it will be minus cosec square x. So this implies dy over dx equals to minus 2 cosec x cot x minus into minus is plus 3 cosec square x. So this is the value of dy over dx, but since we have to find the value of dy over dx at x equals to pi by 4. So now let me put the value of x as pi by 4 in this equation. So it will be dy by dx when x equals to pi by 4, then that time it will be minus 2 cosec pi by 4 cot pi by 4 plus 3 cosec square pi by 4. So if I put the value, then we will have minus 2 cosec pi by 4 is root 2 into cot pi by 4 is 1 plus 3 into root 2 whole square. So it will be minus 2 root 2 plus 3 times 2, and that will be minus 2 root 2 plus 6 is your answer. Okay, next question, number 9. If y equals to root over x by a plus root over a by x, then prove that 2 into xy times dy over dx equals to x by a minus a by x. So here, let me write the given function. First we will find dy over dx, okay? So here y equals to root over x by a can be written as root over x over root over a plus root over a by root over x. Now let us differentiate both sides with respect to x. Then we will have d dx of y equals to d dx of root over x by root over a plus d dx of root over a by root over x. So this implies dy by dx equals to, now since root over a can be treated as constant, so 1 by root a will come in front, then it will be d dx of x to the power, now since root over x can be written as x to the power half, plus here similarly root a is constant, so let me write that in front, so it will be root over a and d dx of 1 by x to the power half. Okay, so this will be equal to 1 by root over a. Now here d dx of x to the power half can be written as nx to the power n minus 1, so it will be half x to the power half minus 1 using the formula, okay, plus root over a ddx of, now here 1 over x to the power half can be written as x to the power minus half. So this will be equal to 1 by root over a into 1 by 2 x to the power half minus 1 is minus half plus root over a. Now here again we will use the formula, that is ddx of x to the power n is n x to the power n minus 1, okay. So let me simplify it further. This will be equal to 1 by root over a into half into x to the power minus half. Here plus into minus is minus root over a into 1 by 2 into x to the power minus half minus 1 is x to the power minus 3 by 2. In these two terms, half and half are common, so let me take out that in front. So it will be half times 1 by root over a into x to the power minus half minus root over a into x to the power minus 3 by 2. So this is the value of dy over dx. Here we need to prove 2xy dy over dx equals to x by a minus a by x, okay. Now let me write the left hand side of the given equation. So left hand side we have 2xy times dy over dx. So this will be equal to 2x. So in place of y, I will write the value of y which is given in the question. So it is root over x by root over a plus root over a by root over x into dy by dx. The value of dy by dx we have found here. So it is 1 by 2 times 1 by root a times x to the power minus half minus root over a times x to the power minus 3 by 2. Okay, now we have to simplify this and we should get the expression written in the right hand side, okay. You can see that this 2 and 2 are getting cancelled. It will be x root x by root a plus root a x by root over x, okay, into 1 by root a x to the power minus half minus root over a times x to the power minus 3 by 2. So this will be equal to, so x into root over x will be x to the power 3 by 2 by root over a plus root over a into x by root over x will be x to the power 1 minus 1 by 2 times 1 by root over a x to the power minus half minus root over a times x to the power minus 3 by 2. So will be equal to x to the power 3 by 2 by root over a plus root over a into x. 1 minus half is half, 1 over root a x to the power minus half minus root over a x to the power minus 3 by 2. Now here we are multiplying binomial with another binomial. So first let me multiply this term with this term. So it will be x to the power 3 by 2 into x to the power minus 1 by 2 by root a into root a minus root over a by root over a x to the power 3 by 2 into x to the power minus 3 by 2 plus root over a by root over a x to the power half into x to the power minus half minus root over a into root over a into x to the power 1 by 2 into x to the power minus 3 by 2. The numerator here, it will be x to the power 3 by 2 minus 1 by 2 divided by root over a times root over a is a minus root over a by root over a is 1, and here it will be x to the power 3 by 2 minus 3 by 2 plus root over a by root over a gets cancelled, so it will be x to the power 1 by 2 minus 1 by 2 minus root over a times root over a is a into x to the power 1 by 2 minus 3 by 2. So it will be equals to, now if I simplify x to the power 3 by 2 minus 1 by 2, then it will be simply x by a minus x to the power 3 by 2 minus 3 by 2 is x to the power 0, and that is 1, so it will be minus 1 plus, similarly this portion will also be 1, minus a times x to the power 1 by 2 minus 3 by 2 will be minus 1. So here minus 1 plus 1 gets cancelled, so we will have x by a minus a by x to the power minus 1 can be written as x. So this was our right hand side, hence proved. If y equals to root over 1 plus cos 2x by 1 minus cos 2x, then find the value of dy over dx. So for this function, in order to differentiate, we need some formula from the multiple angles of trigonometry, and that formula I have written here, that is cos 2 theta can be written as 2 cos square theta minus 1, and the same cos theta can also be written as 1 minus 2 sin square theta. Okay, so we will be using these two formulas here in this function. So here the given function was y equals to root over 1 plus, now since there is cos 2x here, so in place of that cos 2x, let me use this particular formula, the top one. So it will be 2 cos square x minus 1, okay, divided by 1 minus, and in place of cos 2x here in denominator, I will be using this particular formula, that is 1 minus 2 sin square theta. Okay, so it will be 1 and minus minus will get plus 2 sin square x. So why am I using these two formulas here? Because it will lead to a simple value of the function. Okay, and as you can see here, the plus 1 and minus 1 gets 0, plus 1 minus 1 gets 0. So we will have y equals to root over 2 cos square x by 2 sin square x. Okay, and again 2 and 2 gets cancelled, y equals to root over, now since cos square x is there in numerator and sin square x is there in denominator, so this both can be written as cos x by sin x whole square. Okay, and since the square and the square root cancels to 1, so it will be y equals to cos x by sin x, and cos x by sin x is cot x. So actually the given function is simply the cot x function. Okay, so they are just testing the knowledge from the multiple angles of the trigonometry. Okay, so now since the function is very simple, so here we will be using this particular formula, that is ddx of cot x is minus cos x square x. Okay, so let us differentiate both sides with respect to x, then we will get ddx of y equals to ddx of cot x, and this implies dy by dx equals to minus cosec square x. So this is your answer for this question. Okay.